Hello, Prep 1. Today we will revise the parts of our curriculum of geometry till 15th of March in a form of some exercises that common in exams. Let's begin. Complete the following. The regular polygon has equal sides and equal angles. The regular polygons. Okay? The sum of measures of interior angles of the Pentagon. Do you remember our rule that we use to get the measures of any polygons? N minus 2 multiply 180, and N refers to the numbers of sides. Okay, here the Pentagon has 5 sides, so 5 minus 2 multiply 180 equal 540 degree. Let's revise the names of all polygons that we know. If the polygon has 3 sides, it will be triangle, 4 sides quadrilateral, 5 sides pentagon, 6 side hexagon, 7 side heptagon, 8 side octagon, 9 side nonagon. Okay. Number 3. In the parallelogram, each two opposite angles are. Let's revise the properties of parallelogram. Each two opposite sides are parallel and equal in length. Each two opposite sides are equal in length and parallel. Okay. This equal this in length and parallel, and these sides equal these sides in length and also parallel. Each opposite angles are equal in measure. Okay, the sum of two consecutive angles equal 180, and the two diagonals bisect each other like a knife. Okay, here in the parallelogram, each two opposite angles are equal in measure. Number 4, the quadrilateral whose 4 sides are equal is rhombus. Okay, look at these quadrilaterals: rectangle, rhombus, and square. Do you remember them? In the rectangle, each two opposite sides are equal. Okay, each two opposite sides are like the parallelogram and the parallel. Okay, and has 4 right angles, and the two diagonals bisect each other like a parallelogram and equal in length. And here the 4 sides are equal. The 4 sides in the rhombus, the 4 sides are equal, and the two diagonals bisect each other, of course, and perpendicular. Okay, and here my king, the square, because he has all the properties in quadrilaterals. Okay, has 4 sides are equal and 4 right angles, and it's two diagonals equal in length and perpendicular. Okay, so here the quadrilateral whose 4 sides are equal, it's a rhombus. I can't write square because the square needs more than one condition. Number 5, the two diagonals are perpendicular in the first, my king. Okay, and perpendicular the rhombus. Okay. Number 6, the two diagonals are equal, the king, square, and rectangle. Stop. Number 7, the sum of measures of the interior angles equal, as we know, equal 180. It's an old information. The measure of exterior angle of the equilateral triangle at any one of its vertices, equilateral triangle, okay, and he want to get this angle, exterior angles, okay? As we know, to get the measure of this exterior angle, it equals the sum of two non-consecutive angles, equal this plus this. He told us it is an equilateral triangle. So each angle equal 60 degrees. Then this angles equal 60 plus 60 equal 120 degrees. That's all. Let's answer some geometric figures. In the opposite figure, find measure angle AMD. AMD. All of us know the sum of accumulative angles at one point equal 360. So to get this angle, I will write 360 minus all these angles, 120 plus 30 plus 90 equal 120. It's very easy. And here in the opposite figure, okay, DA parallel with CE. DE, the ray of DA parallel with CE. And BA bisect the angle DBE. This ray bisect this angle. And the measure angle ADB equal 48. And the measure angle C equal 66. Prove that the figure ABCD is a parallelogram. We have some conditions to prove each angle or any angle is a parallelogram. Look at the whiteboard, please. To prove that the figure is a parallelogram, each two opposite sides are equal, or we have to prove that each two opposite sides are equal, or each two opposite sides are parallel, or two opposite sides are equal and parallel, or each two opposite angles are equal in measure, or the two diagonals bisect each other. What the meaning of or, I have to prove one of these conditions, not all of them. One is enough, okay? Here, I will use the givens to prove the required. He wants to prove ABCD is a parallelogram, and he gives me this angle, the measure of this angle, and this parallel with this ray. As the first, the angle here DBC equal angle 48 equal this angle, alternate angle Z. Measure angle here DBC equal measure angle ADB, okay, equal 48 degree. Alternate angles, okay? And this angle is a straight angles, okay? This 48. So the measure of EBD equal EBD equal 180 minus 48 equal 132. Okay, this angle equal 132. Right here, and measure angle EBD equal 180 minus 48 equal 132 degree. And since in DBA bisect angle E, B, D. Then measure angle number 1 and number 2. Measure angle 1 equal measure angle 2 equal 132 divided 2 equal 66 degree. Do note that since measure angle 2 equal measure angle DCB equal 66, okay? Okay, here 66, here, then BA parallel with CD. Why? Because this angle corresponding with this angle, corresponding in and out, in and out. And since and DA parallel with CB, it's a given. So the figure is a parallelogram because each two opposite sides are parallel. Okay. Pause, please. Look at this figure. In the opposite figure, DE parallel with FR and parallel with CR or CP. Okay, CP. And measure angle D equal 140, measure angle F equal 125. Calculate the measures of angle of triangle ABC. You want to get this angle and this and this. At the first, this ray parallel with this, parallel with this. So the three rays parallel of each other. Here, this ray parallel with CB, so this angle I'll get it with 180 minus 140. Why? Because these angles is interior angles, okay, are interior angles, and their sum equal 180. So this angle 180 minus 140 equal 40 degree. Okay, number 1. Angle C. Measure angle C. Measure angle C equal 180 minus 140 equal 40 degree. Interior angles. And FR parallel with BC. Then this angle, angle B, measure angle B equal 180 minus 125 also equal 55 degree. 55 degree, here 40 degree and this 55 degree. Okay, measure angle C. I want to get measure angle, this angle AD, this angle. Okay, angle A. The sum of interior angles of any triangle equal 180. So to get the measure angle A equal 180 minus 40 plus 55 equal 85 degree. That's all. Okay. Number 4, in the opposite figure, D belongs to DC here, and measure angle A equal 30 degree. He want to get the measure of ABD. ABD. This angle is an exterior angle of a triangle. We have to get this angle because to get this angle it's equal the sum of two non-consecutive angles. Okay, this angle equal 30 degree. Okay, he gave me the measure of this angle, and he told me that this angle equals this angle, okay, by this sign. To get this angle equal 180, because the sum of triangles, the sum of interior angle of a triangle 180 minus 30 equal 150. 150 equal angle P plus angle C. So measure angle C equal 150 over 2 equal 75 degree. Then measure angle DBA equal 30 plus 75 equal 105 degree. It is an exterior angles. Look at this figure. Find the measure of EBDC. DBC, this angle. At the first, we have to get the sum of angles of this polygon. Count the number of sides, 1, 2, 3, 4, 5. So the number of sides is 5. I can to get the sum of angles by my rule, n minus 2 multiply 180, 5 minus 2 multiply 180 equal 540 degree. So to get measure angle D equal 540 minus all the angles 130 plus 90 plus 90 plus 90 equal 120, I think, or 140. Okay, 140. Thank you very much, and take care of yourself, my dear. Thank you.